All right, let's talk about straight lines. You see them on graphs all the time, right? Well, today we're going to pull them apart, really get into their anatomy, and figure out the super simple formula that's behind every single one. And here it is, y equals ax plus b. It might look simple, but this little equation is basically the DNA for every straight line in the universe. Seriously. By the time we're done here, you're not just going to understand it, you'll be able to build any line you want with it. So, here's the plan. We'll start with the absolute basic blueprint, y equals x. Then, we'll see how to play with the steepness, that's the slope. After that, we'll learn how to shift the line up and down with the intercepts. Then we'll get into how lines relate to each other, parallel and perpendicular stuff. We'll even tackle a practical distance problem, and of course, wrap it all up with the key things you need to remember. Okay, first up, the blueprint. Where does it all begin? With all these different parts, you might be wondering, where do we even start? Well, like with anything complicated, the best way to really get it is to start with the simplest version possible. And here it is, y equals x. This is what we call the identity function, and it's our ground zero. Just look at it. It's perfectly balanced. For every one step you move to the right, you move exactly one step up. It slices right through the origin at a perfect 45-degree angle. This is the foundation for literally every other line we're going to talk about. Okay, now for the fun part. Let's start messing with it. Section 2 is the steepness style, all about understanding the slope, or a. So, that variable a, think of it exactly like a steepness style. See what happens here? When a is 2, the line y equals 2x gets much steeper. It's like we cranked up the dial. This a value gives us complete control over the angle of our line. But what happens if we turn that dial into the negatives? Whoa, the line completely flips over. It becomes a mirror image. Look at y equals negative 2x. It's just as steep as y equals 2x, but now it's heading downhill. That one little negative sign literally reverses the entire direction. It's a total game changer. All right, we've got the angle down. Time for our second tool. Let's talk about the vertical shift, understanding the y-intercept, which is our b. The b in our formula, y equals ax plus b, is the y-intercept. You can think of it as the line's starting point, or its launch pad on that vertical y-axis. It just slides the whole line up or down. No change to the steepness at all. And you can see it right here. We take our basic y equals x line, add a +1, and boom, the whole thing just slides up one spot. It now crosses the y-axis at 1. Change it to y equals x minus 2, and it drops down 2 spots, crossing at negative 2. So that b value is just telling the line where to start, vertically. Okay, so now we know how to build any line we want. So what's next? Let's see how lines relate to each other. Section 4, parallel and perpendicular lines. This is actually super simple. The entire relationship between two lines comes down to one thing, their slope. If the slopes are exactly the same, the lines are parallel. Think of them like railroad tracks. They run alongside each other forever and will never, ever meet. Now, if the slopes are negative reciprocals, what does that mean? It just means you take the slope of one line, flip it upside down, and slap a negative sign on it. If that gives you the other line's slope, then they're perpendicular. And that's the cool part. That whole negative reciprocal thing isn't just some random math rule. Geometrically, it means the two lines cross to form a perfect 90-degree angle, a perfect corner. It's a really neat example of how the numbers in the algebra directly create a very specific shape. Let's look at this in action. See those two steep lines? They have the same slope of 3, so they're climbing at the exact same rate. They're parallel and they'll never intersect. But then look at this third line. Its slope is negative 1/3. What's that? It's the negative reciprocal of 3. And sure enough, it cuts right across the other two at a perfect right angle. It's all right there in the slopes. Okay, we've got the theory. Let's put this into practice with a classic problem. Section 5, a practical challenge, finding the distance from a point to a line. So, imagine you're standing somewhere and there's a street road nearby. What's the fastest way to get to the road? You wouldn't walk at a weird angle, right? You'd walk straight towards it, making a T shape. That's exactly what we're talking about here. The shortest possible distance, d, from a point to a line is always along a path that is perpendicular to that line. Okay, don't panic when you see this formula. I know it looks a little intimidating, but trust me, it's just a recipe. You just plug in the numbers and it spits out the answer. And this isn't just a textbook problem either. This is used all the time in things like video games for collision detection or in robotics. All you need are the details of your line and the location of your point, and this formula gives you that perfect shortest distance. So let's walk through an example. We want the distance from the point -5, 4 to the line y equals 3x minus 2. Step 1, and this is important, we got to get the equation into the right format. We just move everything to one side so it equals 0. So that becomes 3x minus y minus 2 equals 0. Easy. Step 2, we just identify our pieces. A is 3, B is -1, C is -2, and our point gives us x1 as -5 and y1 as 4. Now for the last step, we just plug all those numbers into the formula and solve. See? It takes a tricky geometry question and turns it into simple arithmetic. All right, that was a lot to cover, so let's wrap this up. What are the key takeaways? Okay, here's the bottom line. First, every single straight line can be described by that one simple equation, y equals ax plus b. Second, a is the slope, your steepness and direction control. Third, b is the y-intercept. It just slides the line up and down. And finally, for relationships, parallel lines have the exact same slope, while the slopes of perpendicular lines multiply to equal -1. If you can lock these points into your brain, you've basically mastered linear functions. And that's the thing. These straight lines aren't just for math class. They're used to model pretty much everything, from your phone bill to projecting company profits, even to figuring out planetary orbits. Now that you understand the blueprint, you're going to start seeing them everywhere. So the real question is, where will you see them next?